Hi, I'm Dave Coleman. I'm a vehicle testing manager at Mazda R&D, and I'm here talking about explaining the new Mazda 3, kind of how we made the whole car come together to perform the way it does. This is our third car using our new SKYACTIV technology, which is sort of a big blanket term covering sort of the whole holistic engineering approach that we use for designing these cars. It's very rare for cars to all be designed at the same time, to have the engine and the body and the chassis all designed simultaneously. Usually they're all kind of different projects that get kind of pieced together like Legos. And by doing everything at exactly the same time, we're able to get synergies between different parts of the car that you couldn't get normally. The steering system here is a good example of that. This car uses electric power steering to improve the fuel efficiency, but electric power steering usually kind of has this numb, artificial feel. And since when we were designing this car, we knew that we were only ever going to have electric power steering, we could set up the suspension geometry, the steering geometry differently because to take advantage of sort of the strengths of electric steering. The electric power assist has a lot more flexibility. We can sort of make any assist curves that we want. And so what we did is we built in a lot more caster angle in the front suspension. You can see that the strut angle here is kind of leaned back. In the old Mazda 3, it was leaned back about 3 degrees, which is typical for a front drive car. A rear drive car will typically be more around 5 or 6 degrees. RX-8, for example, was 6.5 degrees. This is also 6.5 degrees, which is pretty much unheard of for a front wheel drive car. With hydraulic steering, it'd be really hard to get the steering effort right. It would usually be too heavy, or else if we assisted it enough to deal with the high forces that caster angle gives us, then it would be too numb the rest of the time. But with electric steering, we have the flexibility to really build in some good steering feedback. This is the body shell of the new Mazda 3, and this is a good example of why designing the whole car at the same time is important. When we designed the engine, we really wanted to get the highest compression ratio we possibly could, because that's sort of fundamental to getting the most energy out of the fuel that we're burning. But there's a lot of challenges to running high compression, the biggest of which is that it's going to typically will cause a detonation or knocking, which can damage the engine. So we have to do a lot of trickery to try to avoid knock. By designing the body at the same time, we were able to design the engine differently, actually. This structure here in the firewall, you can see this reinforcement in this very big tunnel, which is unusual for a front-wheel drive car. This was made to accommodate some design features on the engine that were absolutely necessary to get the compression where we wanted to. We'll jump inside and I'll show you the engine to show you what this tunnel was made for. So this crazy exhaust manifold is what that tunnel was made for. We built what's basically a 4-into-2-into-1 race header on the back of this engine. And the reason we did that is that one of the key things to getting a high compression engine to not knock is to lower the temperature in the combustion chamber. And what the most important thing to do there is to get all of the exhaust out at the end of the exhaust stroke, so none of the hot exhaust gas is diluting the next intake charge. This long exhaust manifold prevents any pulse interference between the cylinders. So this is cylinder number 1. The firing order on most 4-cylinder engines is 1, 3, 4, 2. So what happens is there's a little bit of overlap between the number 3 and number 1 exhaust pulses. This one is just opening the exhaust valve when this one is just about to close the valve. And what happens is you'll have a pulse, if you have a short manifold, the pulse coming out of here at the beginning of the exhaust stroke will come down and bounce back up the number 1 runner and actually push a little bit of exhaust back in there. And then that exhaust will heat up the next charge and make it more likely to knock. So by having this long convoluted path between number 3 and number 1, the pulse has to go all the way down to the second collector and then all the way back up, traveling at the speed of sound. And the time that it takes for it to get that far is long enough that by the time it actually gets there, the exhaust valve has closed and it can't actually shove the exhaust back in there. Just putting this manifold on here let us push the compression ratio from 12-to-1 to 13-to-1. It got us quite a big boost in torque and fuel efficiency. Another very unusual feature of the Mazda 3 that you probably never notice unless I told you about it is the way we make our 2-liter and 2.5-liter engines. They're both exactly the same design, but the 2.5-liter is just scaled up proportionally from the 2-liter. Most of the time when you make 2 different engine families, they'll actually be exactly the same size. We'll just put a bigger bore or longer stroke in the bigger engine. This is the easy way to manufacture the engine using sort of old school manufacturing techniques, using big machines that just do kind of one job at a time. But we build these engines in a very modern factory using CNC machining, which is a computer-controlled machine that can do multiple machining operations at once. And that gives us so much flexibility in design that we're not stuck with having the engines be exactly the same size and all the chip parts be interchangeable. In fact, there's almost no, even though the engines look exactly the same, there's almost no interchangeable parts between them. The 2.5 liter has the same, I think these rocker arms and these cam gears are the same and the bolts are the same, but everything else is different because the whole engine's scaled up proportionally. And the reason we did that is we really designed the engine around having the most efficient combustion process. And if you change the bore or stroke out of proportion with each other, you'll end up messing up that combustion process. So we got the combustion process we wanted, then we scaled everything up in proportion to kind of maintain that at every different displacement. So the key thing at Mazda is all this technology that we're putting into the car to improve the performance and improve the fuel efficiency, we're trying to do in a really balanced way with the focus always on the car being fun to drive. Having a car that's really fuel efficient is important because gas is expensive obviously, but if it takes away all of the joy of driving, what's the point? Real goal with SKYACTIV technology is to be able to get the fuel efficiency that sort of your sensible side wants without having to sacrifice the driving performance and the enjoyment. The numbers aren't necessarily that impressive, but the feel of the car and the way it feels when you bend it around a corner is really where we kind of put our heart and soul. You really have to drive the car to experience it. What's the point? Our real goal with the SKYACTIV technology is excuse me, you can edit that out, right? The real goal with SKYACTIV technology